All right, diving in. Today, machine learning, we've got some really interesting notes to work with
Mm,
from Juma Shafara.
yes.
Now, he's a data scientist,
Hmm.
but he's also working with Raising the Village, which is an NGO, and an instructor at Data Idea.
Right. So he's got a hands in a lot of different areas of machine learning.
Exactly. And that's what makes these notes so interesting.
Yeah.
So no matter what your level of knowledge is,
Hmm.
you can follow along.
Absolutely.
Because he starts like right at the beginning.
Yeah.
And he actually defines it as getting computers to learn without explicit programming.
That's a great starting point.
Okay, it sounds really cool, but like, what does that actually mean?
Well, it's all about using data, right, to train computers to, solve problems and make predictions almost as if they're thinking on their own.
Oh, okay.
Yeah, and it's kind of like imagine teaching a kid to ride a bike.
Okay,
You wouldn't like give them this whole step-by-step manual, would you? You'd kind of let them try it out,
right?
maybe give them some feedback and they'd figure it out on their own through experience.
Yeah.
And machine learning is similar, right?
Yeah.
We feed these algorithms, which are kind of like, sets of instructions, tons of data, and then they learn these patterns.
Okay.
And they use those patterns to make predictions.
So less rigid instructions, more like let the computer kind of figure it out?
Yeah, learn from its mistakes.
Interesting.
Yeah, and this idea actually has been around for a while.
Oh, really?
Yeah, so Arthur Samuel, he's like a pioneer in the field, coined the term machine learning back in 1959.
Wow, okay.
I know, it's been around for a while. He was actually working on this checkers playing program that, get this, got better the more it played.
Like it was learning from its mistakes.
Right. Pretty cool.
Yeah, it almost sounds human.
It really does raise some interesting questions about, like, what does it mean for a machine to learn,
Mm-hmm.
Is it really intelligence? Like Alan Turing, the famous code breaker, computer
Oh,
scientist,
yeah?
he was thinking about this stuff way back when.
Huh.
So yeah, deep questions.
Wow.
But for now, let's get back to Jima's notes.
Okay.
He talks about these four main types of machine learning: supervised, unsupervised, reinforcement, and semi-supervised.
Okay, it's like a whole team.
Yeah, different learning styles.
Yeah.
And each one, kind of like a superhero, each one has its strengths and it's good at tackling different problems.
Oh, okay.
Some need labeled data where we tell them exactly what's what. Others are more like, explorers.
Right.
They dive into this unlabeled data and find hidden patterns and connections.
That's so cool. Before we like get too lost in the technical stuff though,
Sure.
can we see some real-world examples of this, like machine learning in action?
Absolutely. Think about when you're on Google, you're typing in a search.
Okay.
Have you noticed how it seems to know what you're looking for?
Yeah, yeah.
Like even before you finish typing,
Uh-huh.
that's machine learning.
Oh, wow.
These algorithms are analyzing your past searches and they're predicting what you're interested in.
So it's like Google has a mind-reading sidekick
Kind of.
powered by machine learning.
Yeah.
Wow, what else?
Well, how about those spam filters that keep all the junk mail out of our inboxes?
Oh, thank goodness for those.
Right. Machine learning is behind that too.
Really?
Yeah, they're trained on these huge data sets of emails to learn how to spot the difference between, good emails and the spam.
That's a lifesaver.
It is, it is. And then, those personalized recommendations you get on Netflix or
Oh.
Amazon, that's machine learning too.
No way.
Yeah, it's looking at your viewing history, your purchase history, and figuring out what you might like.
Wow, it's like everywhere.
It really is.
Machine learning's just like woven into our lives.
Yeah, totally.
Wait, but hold on, we can't forget that even these super smart algorithms need like good ingredients to learn from.
That's a good point.
Juma emphasizes data pre-processing. What's that all about?
Think of it this way. You're making a meal.
Okay.
You wouldn't just throw all the ingredients in a pot without doing anything, would you?
No.
You have to watch them, chop them, season them.
Right.
Data pre-processing is kind of like that for algorithms. You're getting the data ready for them to use.
So what kind of prep work are we talking about?
Well, Juma mentions things like standardizing and one-hot encoding. Now, these might sound a bit technical,
Yeah, a little.
but really the goal is pretty simple. Like standardizing is making sure that different types of data can be compared. It's like, if you're following a recipe, converting cups and teaspoons to milliliters so everything's consistent.
Right, right.
And then one-hot encoding, that's about transforming categories like colors or types of fruit into a format the computer can understand.
Huh. It's interesting how much goes on behind the scenes before those algorithms even start learning.
It is.
But okay, let's be real. The stars of the show are the algorithms themselves.
Of course.
Juma's got a whole list here. Linear regression, logistic regression, decision trees, support vector machines. Like, whoa.
It can be a lot, but each one is kind of like a special tool, for a specific type of problem.
Can we take a peek inside that toolbox and see how they work?
Sure, let's start with decision trees.
Okay.
Imagine playing 20 questions where you're trying to guess what someone's thinking of, right?
Uh-huh.
So you ask these yes or no questions.
Yep.
And a decision tree kind of works like that. It makes a series of decisions based on the data to reach a prediction.
I get that. Okay.
Yeah, pretty easy to visualize, even for beginners.
All right. What about those support vector machines? The name sounds a little intimidating.
Yeah, it does, but don't worry. Imagine you have a bunch of marbles, all different colors, scattered on a table.
Okay.
A support vector machine is like trying to draw a line to separate those marbles by color.
Oh, like drawing a line in the sand?
Exactly. But with math.
I'm starting to get it. But before we go too deep into the world of algorithms, what about the big picture? What are the advantages and disadvantages of using machine learning to solve problems?
That's when it gets really interesting. Juma's notes go into both the good and the bad of machine learning.
Oh, okay.
It's like any powerful tool, you can use it for good or for bad.
Hmm.
And understanding both sides is important.
Yeah, so let's start with the good. What are the major advantages of using machine learning? Like, what makes it so revolutionary?
Well, first off, it can find things hidden in massive amounts of data.
Oh, okay.
Imagine you're a doctor and you're trying to diagnose a rare disease.
Mhm.
You could spend hours and hours looking through medical journals and records.
Right.
But machine learning algorithms can analyze huge data sets in a fraction of the time
Oh, wow.
and potentially spot patterns and connections that a human might miss.
So it's like a superpowered research assistant
Yeah,
working tirelessly.
exactly. And not just in healthcare. Think about businesses.
Oh, okay.
Trying to understand customers or scientists, analyzing climate data.
Yeah.
Machine learning can help us make sense of all this information.
It's like finding a needle in a haystack, but without all the searching.
Yeah.
What else is there?
Automation is a big one.
Okay.
Machine learning algorithms can handle repetitive tasks,
Right.
which frees us up to do more creative things.
Oh, that's two.
Like, remember those self-driving cars we talked about?
Yeah.
The algorithms are constantly learning and adapting to the road,
Wow.
so the driver can just relax.
That's both futuristic and relaxing.
Right.
Yeah. But it does make you think about the future of work.
Yeah, true.
We'll have to talk about that another time. What other advantages did Juma mention?
Well, he talked about continuous improvement. Unlike regular computer programs that follow set rules,
Mm-hmm.
machine learning algorithms can actually get smarter over time.
Oh, interesting.
As they see more data, it's like a student who learns from their mistakes.
So the more data it sees, the smarter it gets.
Exactly.
Like a digital brain that's constantly growing.
Yeah. But we got to be realistic, too.
Right.
Juma also pointed out the downsides to machine learning.
Okay, yeah, every rose has its thorns. What are some of the challenges?
Bias is a big one.
Okay,
Because algorithms are trained on data created by humans, our biases can end up in there.
right.
And if we're not careful, the algorithms can actually perpetuate those biases.
So it's not enough to just feed the algorithms data.
Note.
We need to be careful about the quality of that data.
Exactly.
Make sure it's not making things worse.
And even with good data, machine learning isn't perfect.
Oh, right.
Algorithms can still make mistakes, especially with situations they haven't seen before.
So we shouldn't just blindly trust the machines,
No, definitely not.
but use them as tools to help us.
That's the key.
Okay, let's shift gears a bit and talk about those 4 main types of machine learning Juma mentioned.
Okay.
Can you walk us through the differences and give us some real-world examples?
Sure, let's start with supervised learning. Imagine you're teaching a kid about different fruits.
Okay,
You show them an apple and say, this is an apple, then you show them a banana, this is a banana.
right.
That's what we do with algorithms in supervised learning.
Oh, okay.
We give them labeled data, so each input has a matching output.
So we're giving it flashcards with the questions and answers,
Yeah.
and it learns from those.
And there are 2 main tasks within supervised learning, classification and regression.
Okay.
Classification is about sorting data.
Like, is this email spam?
Exactly. Or is this picture a cat or a dog?
Yeah, okay.
Regression is about predicting a value.
So, like, what will the temperature be tomorrow?
Yes. Or how much will this house sell for?
Okay, so supervised learning is all about learning from those labeled examples.
Right, to make predictions about new data.
Got it. What about unsupervised learning?
That's where things get a bit more exploratory.
Okay.
Imagine you get a box of Legos, but there are no instructions.
Mm-hmm.
You don't know what to build, but you start putting pieces together.
Right, looking for patterns.
Exactly. So unsupervised learning is less about a specific goal
Okay.
and more about letting the algorithm explore the data.
Cool. Can you give us an example?
Sure, think about those music streaming services
Okay.
that recommend songs you might like.
Yeah.
They don't know your taste exactly,
Right.
but they can look at what millions of users are listening to
Mm-hmm.
and group them based on similarities.
So they're finding your music tribe,
Yeah,
all thanks to unsupervised learning.
that's right.
Now, what about reinforcement learning?
That one's all about trial and error, rewards, and penalties, like training a dog.
Oh,
You
okay.
throw the ball, the dog brings it back, you give it a treat.
Positive reinforcement.
Right, so the algorithm learns to do things that lead to rewards.
Okay, and avoid the things that lead to punishment.
Exactly. It's used in all kinds of things, from robots to traffic flow.
That's amazing. And lastly, there's semi-supervised learning.
Right, that's kind of a mix of the two. Think about learning a new language.
Mm-hmm.
You might have a textbook with some rules,
Yeah,
but you also listen to music and talk to native speakers.
right. So you're getting information in different ways.
Exactly. So in semi-supervised learning, we have a little bit of labeled data
Okay.
and a lot of unlabeled data.
Mm-hmm.
And the algorithm uses both to learn.
So it's like a teacher giving you hints,
Yeah,
and then you figure out the rest.
that's a great way to put it. So we've got supervised, unsupervised, reinforcement, and semi-supervised.
Got it. But I'm curious about how Juma's using all this with Raising the Village. How is machine learning helping people in those last-mile communities?
It's really amazing. His notes show how they're using machine learning to tackle some really tough problems.
Like what?
Well, one example that stood out was their work on clean water access.
Oh, right.
In remote areas, it's really hard to find good water sources.
Yeah, bet.
So they're using satellite images and data with machine learning algorithms
Okay.
to analyze the land, look at the plants and the environment.
Uh-huh.
And these algorithms can actually pinpoint spots where there's likely groundwater.
Wow, so it's like a high-tech treasure map for finding water.
Exactly. And it saves a ton of time and resources compared to traditional methods.
That's incredible. And is it just about finding water?
No, they're also using machine learning to get things like medical supplies and educational materials to the right places.
So like making sure the aid gets where it's needed most.
Exactly. It's about efficiency.
It's like a super-powered delivery system.
Yeah. And they're even using it for education.
Oh, really?
They're tailoring learning materials to each student's needs.
Wow, like a personalized tutor.
Exactly. And that's not all.
What else?
They're looking at early warning signs for disease outbreaks.
So they can act quickly and prevent things from spreading.
Exactly. Machine learning is like a guardian angel for these communities.
Juma's work is really inspiring. It shows how machine learning can make a real difference in people's lives.
Absolutely. And I think that's a key takeaway from today.
Yeah,
Machine learning isn't just some abstract concept.
right.
It can be used to solve real problems and make a positive impact.
Well said. As we wrap up this deep dive, I feel a sense of, like, wow, the possibilities are endless.
Yeah, this field is changing so quickly.
It's up to us to make sure it's used for good.
We've covered a lot today.
We did, from the basics of how machines learn to the ethical stuff and Juma's work.
Yeah, and we've seen how it's changing industries, leading to innovation, and even helping us understand ourselves better.
It's mind-blowing, but we can't forget it's still a tool,
Right.
and we have to use it responsibly.
Absolutely. To our listeners out there, stay curious, keep learning,
Yes?
and think about the role you want machine learning to play in your life.
It's shaping the future.
It is. This has been an amazing deep dive.
It really has.
And I'm sure there's so much more to come in the world of machine learning.
Until next time, keep exploring and keep asking questions.
And remember, the future is ours to create.